This is Algebra 2, test number 12. Got through lesson 5.4 where we're dealing with complex numbers, first study guide. You have to graph on a complex plane. Remember what graphing on a complex plane is real simple. X is your real number, and Y, you're typically what your Y-axis would be. That's your imaginary number. So the number negative 4 minus 2I, X is what's typically your X-axis is negative 4. And what's typically your Y-axis is negative 2. There's two of them that show up like that. We have this point here is negative 4, negative 2. This point here is negative 4, negative 2. This one up here is positive 2, negative 4, positive 2, so that's not the right one. And then this one right here is negative 2, negative 4, so that one has them backwards. So it's either A or C. We got to determine which one it is based on what each axis says. Notice that the axes are labeled opposite. For this one, it says the x-axis is your real axis. For this one over here, it says the x-axis is your imaginary axis. That's not correct. Remember, the one going across, the first one is your real axis. So this one, this is incorrect. Therefore, C is the correct one. Number 2 says simplify the square root of negative 63 using the imaginary number I. First thing you want to do is take that negative out of the radical. So multiply it by I. So it's the same thing now, except the negative's gone and it's multiplied by I. Then simplify it using a perfect square. Remember what your perfect squares are. 2 times 2, 3 times 3, 4 times 4, those numbers. 9 is the number you want to use. So the square root of 9 times the square root of 7 gives you 63. Don't forget that there's an I here. You got to bring that down every time. So the square root of 9 is simply 3 times the square root of 7 times I. And then we just want to write it in a better order. Remember, it's not just 3. It's both positive and negative 3 times I times the square root of 7. That's just the best order to write it in. Remember, it doesn't matter what order you multiply in. As long as you include both positive and negative, you won't have to choose between this answer and this answer. You'll have the correct answer as long as, again, you include both positive and negative. So for these, we have complex numbers where we have a real part and an imaginary part. These are not pure imaginary numbers like number 2 was. So the same thing holds true, though. You want to get this negative out from under the radical by multiplying it by I. So I times the square root of 9 is I times 3, which is going to be 3I. Remember, again, just to put it in correct order. And then you have plus 5. But it's not just 3I. It's both positive and negative 3I. So right here, in order for it to be in a correct order, you want it to say A first and then be I. So A's value would be 5 plus or minus 3I. 5 plus or minus 3I. For number 4, 9 minus the square root of negative 72. Again, you need to do radicals before you try to subtract. It's still order of operations. Please excuse my dear Aunt Sally. So you want to, first thing you want to do is take this negative out again by multiplying it by I. Bring the rest of it down. 9 minus that. Keep writing 79. I don't know why I keep my 9s and my 2s confused today. But 72. Again, take a perfect square out of 72. You might not know what the perfect square is. You might not know what its largest factor is, I should say. But you know, just based back on number 2 right here, we use 9 times 7 to get 63. You know 9 goes into it. So let's say we took that route. 9 multiplies by 8. Okay? The square root of 9. So again, the square root of 9 is 3. And again, that's positive or negative. You can put it to where you don't forget it. Positive or negative times the square root of 8. Now look at this one. And I know we have more stuff to bring down from there. But the square root of 8 has a perfect square in it as well. So if you separate that one, its perfect square is 4, and it's multiplied by 2. So the square root of 4 is 2. That's multiplying by 3, because this has to come down. And again, it's still both positive or negative, times the square root of 2. So 3 times 2 is both positive or negative 6 times the square root of 2. And if we bring all the rest of this down, I know it took a little while to get it down here, 9 minus I times that. So if we put all of this in a better order to make it say A plus BI, it's going to say 9, because that's first, that's your A value. Okay. It's going to be both plus or minus, and then it's going to be 6I times the square root of 2. Now, I know that there is a negative or a minus here, but remember, it does, if you use a positive 6, then that negative is going to be negative. If you use a negative 6, that negative is going to turn back to be positive. That's why it's both positive or negative for that one. Again, you could have done all of this work here, all of this, in one step by separating 72 into 36 times 2. But most of us, when we see the number 72, we don't think of the perfect square 36. So I just want to show you that if you took 2 steps to do it, that's okay. Number 5 says to simplify the expression. Remember, imaginary numbers act just like variables when it comes to adding and subtracting like polynomials. So negative 5 plus negative 3. Negative 5 minus 3 is negative 8. And negative I plus 4I. Negative I plus 4I is positive 3I. Negative 8 plus 3I. Then we're factoring these expressions. Now, number 6 was a little confusing for people when they first looked at it, because they thought, well, I got to undo something. I got to undo this. I got to undo that. But there's no equal signs. Remember, you only undo operations when you go into the other side of the equal sign. That's not what you're doing here. You simply factor in these. There's no equal signs at all. So there's 2 terms here, negative 12x squared and negative 28. You want to factor out what they have in common. They both have negative in common for sure. And then what's the largest number that goes into both of them? 2 goes into them, but there's something larger. 4 goes into both of them. So negative 4. And then they both have an x in common. One's got x to the first, one's got x to the second. So the smallest factor that or the largest factor that goes into both of them is x. So negative 4x. And then open up a set of parentheses. What you're doing is you're distributing in reverse. And you're asking yourself, negative 4x times what gives you negative 12x? If you multiply 3 times negative 4, you get negative 12. And if you multiply x times x, you get x squared. Also, what times negative 4 gives you negative 28? That would be a positive 7. And if you multiply x times 1, which you don't have to write, you get x to the first power. So this is your factored out version. You took out negative 4x, and it's multiplying by 3x plus 7. For number 7, you have a trinomial. That means you need to make 2 binomials out of this one. Its a value is 1, so you do x times x to get x squared, and you factor out c. Your factors of c that get you to b's value are, in order to get to 56, you can do 1 times 56. It's an even number, so you know 2 goes into it. 2 goes into 50 25 times, so it's got to go in 6 times, got to go 3 more, so it'll be 28. 3 doesn't go into it. 4 does. 4 goes into 15. It goes into 5 once, and it goes into 16 4 more times. So 14. 5 doesn't go into it because it doesn't end in a 5 or 0. 6 doesn't go into it. 7 does, and 7 multiplies by 8. So those are your 4 pairs of factors to get to 56. Which one of those numbers gets you to 15? Or which pair? That's right. The only pair that'll get you there is 7 and 8. If you use any other pair, you won't get to b's value. Remember, this sign tells you they're either the same or they're different. Since it's plus, they're the same. And since they're both the same, they're both positive. So plus 7 plus 8. We're going to do the same thing with number 8. X times x, since a's value is 1. In order to get to 80, 1 times 80 2 times 40. 3 doesn't go into it. 4 does, though, times 20. 5 goes into it 16 times. 7 doesn't go into it. 8 goes into it 10 times, and then 9 doesn't. So one of those pairs gets you to 18. Which one of those pairs gets you to 18? The only one is that last one. The rest of them will get you the numbers that aren't 18. So you got to use 8 and 10. Again, this sign, same or different. Plus means same. This sign, since they're the same, they're both negative. Negative 8, negative 10. Number 9, x squared plus x minus 6. Again, even same thing, except simpler because you have even fewer pairs of factors, 1 and 6 and 2 and 3. Those are the only ones you can use. But your b value isn't shown. Remember what your b value is? It's 1 right here, whatever's multiplying times x. So the only pair that'll get you to 1 out of those two is 2 and 3. If you put 1 and 6 together, you're going to get 7, or you're going to get 5. This sign right here tells us they're opposite signs, unlike number 7 and number 8, which were the same signs. These are opposites. Since they're the opposites, this one tells you the sign of the larger value. 3 is larger, so it's positive. They're opposites, so 2 is negative. Now, 10 and 11 are special circumstance kinds that you can simplify. Number 10 is called a perfect trinomial. Okay, a's value is not 1 like the last few have been. But this is a perfect trinomial. You can take the square root of the a. The square root of 9 is 3. The square root of x squared is x, 3x. And you could take the square root of the c value, 25, is 5. This sign is the one that goes in between them, so plus 5. And then that entire binomial is being squared. If you square that and you multiply 3x plus 5 times 3x plus 5, you'll come back to the trinomial, 9x squared plus 30x plus 25. Number 11 is another special circumstance. It's the difference of two perfect squares. Difference because they're minus, and you could take the square root of this, 5x, and you could take the square root of this, 2. Remember, with the difference of two perfect squares, it's 5x and 2 and 5x and 2, but one of them is positive and the other one is negative. One's plus, one's minus. That's the difference of two perfect squares. Number 12 says solve the equation by finding square roots. Order of operations, you still work backwards on it. You still want to get x equals all by itself. So undo 5 times that by dividing by 5. If you do it there, do it here. X squared equals 10. And then get rid of squaring something by taking a square root. If you do it there, do it here. Now, this cancels out this. There's no perfect factor in 10, so x is both positive and negative square root of 10. And again, if you left out the positive or negative, just add it in. Get in the habit of doing that now, and it makes things we do in the future a whole lot easier. 13, simplify the radical expression. This is the square root of 36. What number times itself is 36? Both positive and negative 6. The square root of 450 over 10. You can divide it before you separate it. Some people chose to separate it, then you had to rationalize the denominator. 450 divides by 10. It gives you the square root of 45. And then there's a perfect factor in 45, 9 times 5. The square root of 9 is both positive and negative 3 times the square root of 5. This is rationalizing the denominator. You cannot leave that radical at the bottom. Whatever's on the bottom, you multiply it by that over itself. So if you go straight across, 3 times the square root of 5 is written just like that, 3 times the square root of 5. And the square root of 5 times the square root of 5, if you put those two together, you get the square root of 25, which simplifies right back to 5. So whatever's underneath that symbol, that radicand, 5, you simply put it as 5. So 3 square root of 5 over 5. This answer would be both positive or negative. But just for the sake of not making a mistake, we'll just do the principal value right now. 3 times the square root of 5 over 5. 8 times the square root of 20. There's a perfect factor in 24 multiplied by 5. So this is 2 times the square root of 5. Bring this 8 down. That's what people forget. It multiplies by 2. 16 times the square root of 5. And again, that'll be both positive and negative for both of those. 16 times the square root of 5. Same perfect factor in 12. 4 again. Except this time it's times 3. 2 is the square root of 4 times the square root of 3. And again, both positive and negative 2 square root of 3. Negative 1 minus a negative means plus a positive. Negative 1 plus 7 is positive 6. Negative times a negative is a positive. 6 times 3 is 18. Negative divided by a positive is a negative. 28 divided by 7 is 4. 21 says simplify the radical expression. Remember, you can't have a radical at the bottom of a fraction, so you have to rationalize it. Whatever's on the bottom, in this case the square root of 7, you multiply by that over itself. That's called rationalizing. If you go straight across, 2 times the square root of 7 is written just like that. 2 times the square root of 7 over the square root of 7 times the square root of 7 would be the square root of 49, which is going to go right back to being whatever that is, 7. The only other thing you need to do besides that is make sure you can't simplify 2 over 7. Had that been an even number at the bottom, we would take 2 out, but since it's not, we'll leave it like that. Again, this one could also be plus or minus, but we'll just write the principal one right now to where nobody gets confused for this. Multiply and simplify if possible. We can multiply these two together and get the square root of 50. And then take the perfect square out. Remember what your perfect squares are. 2 times 2, 3 times 3, 4 times 4, 5 times 5. Those numbers. The square root of 25 comes out, and it multiplies by the square root of 2. What is the square root of 25? Or what number times itself is 25? We know that that's both positive and negative. 5 times the square root of 2. Another way to do this problem is to notice that this says the square root of 5. That's a factor in 10. You could actually separate the square root of 10 into the square root of 5 times the square root of what? 2. And then notice that you're multiplying the same radical by itself and just pull a radical out. So 2 different ways, and again, both positive and negative, to get to the same answer. Whatever way works for you works for the answer. 2 plus the square root of 7 squared. You're squaring the entire binomial. That means 2 plus times the square root of 7. 2 plus the square root of 7 times 2 plus the square root of 7. You have to FOIL this. First 2 terms, F. 2 times 2 is 4. O, outer 2 terms. 2 times the square root of 7. It's positive 2 square root of 7. I, inner 2 terms. 2 times the square root of 7 again. So positive 2 square root of 7. And then last 2 terms, L. Square root of 7 times the square root of 7 plus 7. Remember, that's the square root of 49. Which again will go right back to being plus 7. At this point, put your like terms together. 4 can go together with 7 and give you 11. And 2 square root of 7 can go together with 2 square root of 7. 2 plus 2 is positive 4 square root of 7. FOIL this one, just like 23, except you don't have to write it out first. So the square root of 5 times the square root of 5. Notice that's the same radical multiplying by itself, so that's going to be positive 5. The square root of 5 times the square root of 5 would be the square root of 25, again, which will come right back to 5. So if you can do that, it'll save you a little bit of effort. The square root of 5 times a negative outer term, square root of 10, is negative square root of 50. We just did the square root of 50 a minute ago right here. We know what the square root of 50 is going to reduce to. So if you can save a little step on a test like that, save you a little work, then do that. Square root of 50. Inner 2 terms, square root of 10 times the square root of 50. Positive square root of 50. But before we even reduce it, we've seen something else happen just now. And square root of 10 times a negative, last term, square root of 10, is negative. That'll be the square root of 100, which comes right back to 10. Right here we have like terms. Let's look at these first. Negative square root of 50. Positive square root of 50. What do those two do with each other? They cancel. That's right. They go on. So you don't even have to reduce them anymore. And you simply have 5 minus 10, which is going to be negative 5. 25 says 3 times negative 4y minus 1 plus 9y. You have to distribute. 3 times negative 4y is negative 12y. 3 times negative 1 is negative 3 plus 9y you still have. Combine your like terms, negative 12y and positive 9y, negative 3y. You still have minus 3 up there. Can't put these two together because they're not like terms. Negative 3y minus 3. Solving all of these Algebra 1 equations, all these real simple. Get variables on both sides, probably one of the tougher Algebra 1 equations. Get them on the same side. Negative 9y is smaller than negative 6y, so bring that one over by adding 9y on both sides. If you do it there, again, do it here. Negative 6y plus 9y is positive 3y. You still have negative 15 here, and you still have equals negative 6. You brought your y's to that side, so we're trying to get y equals by itself. We're going to bring everything else to the other side. Everything else is negative 15. Add it to undo it. If you add it there, add it here. Opposite signs, negative 6 and positive 15. Subtract them. 15 minus 6 is 9. 15 is a higher absolute value, so it's positive 15, so therefore it's positive 9. We still have 3y over here on this side. Get y by itself by dividing by 3. If you do it there, do it here. 9 divided by 3 is 3. Y is 3. 8y plus 8 is equal to 6 times y minus 6. Distribute again, 6 times y and 6 times negative 6. So 8y plus 8 equals 6y minus 36. You want to get y by itself, bring the smaller, always collect your variables on the same side. Bring the smaller 6y over by subtracting it. 8y minus 6y is 2y. You still have plus 8, and you still have equals, don't lose this, negative 36. 2y's on the left-hand side, so we're trying to get our y's by themselves. So subtract everything else on the other side. Subtract 8 on both sides. 2y now is equal to, if you subtract 8, negative 44. Then get y by itself by dividing by 2. A negative divided by positive is a negative, and 44 divided by 2 is 22. Negative 22. Undo your order of operations in reverse. You only have variables on one side on this one, real simple. Undo plus 4 first by subtracting 4 on both sides. You do it there, do it here. Same signs, negative 3 and negative 4. Add them up and get 7 and keep the common sign negative. Negative 7 equals x over 8, which means x divided by 8. Cancel out divide by 8 by multiplying by 8. If you multiply to right, do the same on the left. If I asked you what's a negative times a negative, you'd say positive immediately. Right here we have a negative times a positive, so just think backwards in terms of this one. Same logic, is a negative. 8 times 7 is 56. 29, 5 plus 8n equals 53. We started out tougher and we're getting easier as it goes. Move 5 over by subtracting 5 on both sides. 8n is equal to 48. And then divide by 8 on both sides. N is equal to 6. Distribute first. 4 times y is 4y. 4 times 7 is plus 28 equals 36. Want to get y by itself. Subtract 28 on both sides. 4y, excuse me, is equal to 8. And then divide by 4 on both sides. Y is equal to 2. (31) says 4f of x is equal to 2x minus 7. Find f of negative 1. So in place of x, we're going to plug in negative 1. So 4f of negative 1 equals 2 times negative 1 minus 7. So just simplify this. 2 times negative 1 is negative 2. Negative 2 minus 7 is negative 9. So f of negative 1 is equal to negative 9. Graph the equation. Y equals 8 over 5x minus 1. Y equals mx plus b. Remember, b tells you where to begin. Don't forget that there's a negative there. Tells you where to begin. On your y-axis, you're going to begin at negative 1. Remember, this one's your y-axis, the one going up and down. So at negative 1 is where you're going to begin. Your slope, your m value, says 8 over 5. Remember, m is rise over run. It tells you how much it's either going to go up or down over how much it's going to go left or right. 8 is a positive value, so you're going to go up 8 times. So from here, 1, 2, 3, 4, 5, 6, 7, 8. You're going to go up that many times. And to the right, 1, 2, 3, 4, 5. You're going to the right since this one's a positive value. So up 8 times, into the right 5 times, and then just draw yourself, not like that, draw yourself a straight line through your 2 points. That's how your graph should look. Then 33 says find the slope. M is equal to y sub 2, the difference of y minus y sub 1, over x sub 2 minus x sub 1, the difference of x. This is x and this is y. This is x and this is y. Remember, it's alphabetical if you ever get stuck. This is 0.1. This is 0.2. And just plug it in. So 11, y sub 2, 11 minus y sub 1, that's this, negative 11, over x sub 2, that's this, 1, minus x sub 1, negative 2. Minus a negative means plus a positive. 11 plus 11 is 22. Minus a negative again means plus a positive. 1 plus 2 is 3. There's no number that goes into both of these. So your slope is 22 over 3.